Okay, so let's go to a practical example on simple linear regression. I chose to do with a Pokemon database. Let's start by importing the needed libraries. We will need some others later, but I will import the others as we go through here. API pandas, basic of any machine learning application. Then I'm gonna create our data frame by reading the CSV file. It's in the same directory, so I really just need to put the name of the directory. We can run a sample. I run a sample of like 9, too much maybe. Anyway, so yeah, we can see here all of our columns. It's chose randomly. Now we can run a summary. It's not summary, the function. It is actually describe. Yeah, describe. So this table here, describe function, is where we're gonna define our feature to be used in the model. Okay. So total will be our target value, the value we're gonna predict, of course, because it's like not the sum, but that's the more how do I put that? That's the more logical thing to be our output. And for our feature, we can choose one of them. We have a bunch of numbers here and these things, but what we're looking for is some good range in minimum and maximum. We wanna avoid outliers, but we won't have any outliers here. We can see that some values are pretty distant here, like special defense, 75% of the Pokemons has 90%, but the maximum is 230. In normal cases, we might think that it could be an outlier, but in Pokemon we have legendaries. The legendaries Pokemons, they have much more stats than the others, so it's normal here. Okay, so what we're looking for here is basically a value that influences the total stats here, and a value that has a large variety. Oh, this word is hard for me. My bad. Okay. Anyway, speed, we can see that it has a low max cap, so maybe no speed. Defense and special defense, we know that they do not influence that much in total stats, and so yeah, probably we're looking for attack, HP, or special attack. Okay. We gotta know our data. Okay. I know that Pokemon, it works that way for stats at least. So yeah, and also you can see here some interesting fact that the maximum generation is 6, so it's up to the 6th generation. So after describing it, we can select some few features that might be a good independent variable. Just call like columns data frame. So we're gonna take our data frame and select. Okay, it will be 3, so 4. We're gonna select our target as well. Our target's total. We have HP, we have attack, and I have special attack. I guess there's a space here. Yeah, there's a space here. You gotta be careful with these spaces. We need to put the spaces here. Okay. Now that we selected the features, we can visualize them with histograms to determine which one would be a good feature. Here probably will be attack and special attack, but I'll explain why later. I guess we can just put like this. Yep. We just use function history here, histogram, and yeah. Here what we're looking for is for a spread. Okay, so we don't want our values to be like too focused on one value specifically. The x-axis here is the maximum cap, and the y-axis is the amount of Pokemons that has this value in stats. Okay, so for example, attack has a maximum cap of 190, so it goes around here. But you can see that like most of the Pokemons have an attack of like from 40 to 90, for example. Okay, in HP we can see that it's much more focused on maybe this range here, like 40 to 100, 40 to 60. So yeah, HP might not be a good lead for us for being independent variable. Special attack can be a good one as well. Yeah, basically those two, they have some reasonable spread. There's nothing too extreme here. It won't be too extreme, but because we know that the data is already good for us. The Pokemon won't have any outliers. And yeah, okay, but we can run that to see. Anyway, okay, plot scatter graph to see linear relationship, yeah, between variables. It's like between target and feature. It will be only one feature because it's gonna be a simple linear regression. To plot that is really simple actually. We just call plotlib. Yeah, we call the x-axis, the y-axis. Y-axis we won't change. Will be our target, our total. We can label it, so we're gonna label and we're gonna show it. Alright, we can do the same with special attack. Special attack, it's ATK only. Yeah, special attack, and we can run one more for HP. And it's not attack special attack here. HP. HP will be a little bit different. I guess will be a lot different actually. Yeah. Okay, so what we're looking for here? In the ideal scenario, we would look for tilted dots. Like imagine like if they were clouds, okay? Like a dot here, and it has to be linear, okay? So as our x-axis increases, our y-axis should increase or decrease, but it has to be linear. We can see that they both here are pretty linear, so the more attack they have, the more stats they will have as well, normally, okay? We will have some like this one, but probably these Pokemons have HP or really high defense. But in general, they are linear, okay? Here too, if we put a line here, a line is our model, okay? So if we put a line here, passing through them, we can see that it can work as a linear model. And HP, yeah, it won't work as well as the others. We could see that in our histogram as well. HP, it doesn't influence it that much, and also it's not linear. You can see that like if you plotted a line here, a linear line going through will be way off. Okay, so we're probably using special attack and attack to test our model. Probably the evaluation, the loss, the MSC will be almost the same for these two, but we'll test. So okay, these steps I did is just for us to choose our feature. So probably attack and special attack, okay? We chose our feature already. What do we do now? We split actually before splitting we got a extract, right? So extracting x and y. So for us to extract, we wanna extract only one, so only attack, and here we wanna extract total, and we'll pass 2 numpy and 2 numpy, okay? So it's gonna return us numpy array extracted. We can't see with NP shape, but actually let's see after we train our model. I didn't import skitlearn, so I imported it right now from skitlearn model. Yeah, we're splitting the test size and training size, test and training data sets. So here usually we wanna split like 20 to 30% of that size. Yeah, it's common. And basically like smaller data sets requires a larger test size. Okay, so if we go here, we can see that we have 800 data. Okay, 800 Pokemons. It is a small data set, okay? 800 Pokemons. A really small one actually. So we could test with 30%, but let's test with 20% because like even though it's in smaller data sets, we usually use larger test sizes. It can decrease the evaluation performance in general. So let's test with 20% and 80% to train. Okay, let's run that. It gave me an error. What kind of error is that? Well, oh wait, we don't use it that way. Actually, it's in that way that we use it. What the hell? Okay, now you work it. Now pass numpy, and now we can see our type of, let's say, xstring and the shape. So np.shape xstring. It either can return a one-dimensional array or a two-dimensional array. It depends on the data. Oh, wait a minute. Okay, so it's a array and it's a one-dimensional array. We can see that it's only one. Okay, so now we wanna train our model. Okay, first we need to create a model object. So we got a from sklearn. So not importing this, we're importing linear model, and then I'm gonna call regression, I guess we can understand that. Linear model, linear regression. Okay, it's basically just creating a model object here, and again it's not model selection, it's only sklearn. Okay, now we can train our model. For us to train our model, we just use .fit. Okay, it's gonna require our x and y, so we're gonna pass our training and our y training as well. We saw that the x training is one-dimensional. Okay, if I pass and shape y train, one-dimensional as well. If I try to run this, we have a traceback. Why? Because the fit model, it expects a two-dimensional array for our first variable here, our y training. It expects like an array with observation, and feature. Here we have only features. How do we fix that? We can reshape our array, okay, and it reshapes automatically, so it's pretty easy. We just pass reshape and we pass -1 and 1. Okay, -1 will be the number of observations. It is basically telling that like you get the observation numbers by yourself, and 1 is just the features, right? So if you want that, it's working now. So let's just put that, and let's now print a coefficient. I don't know how to write that. Coefficient and intercept. Okay, pretty useful. After we train the model, this fit function will return us our models on these variables as well, so you can print them. But coefficient is 2. We can print like 0 because it is a simple linear regression, so we have only one coefficient, right? So that is what our model returned us, and now we can visualize our model. Okay, so the same as plotting the scatter. This plot here will be a little bit different because we don't have plot here, and this plot is pretty much our model we're plotting. So what we pass? We pass our x. We're gonna pass our coefficient, so our regression and coefficient, multiply it by our x train. We don't need to reshape here, and yeah, that's it. We're gonna add our intercepts and R. We can label it attack in total. Is it attack that we trained for? Yeah, attack. If we run that, we can see our model. This red line here is our model. We have some far data points here and there and there. Again, probably these are the legendary ones. So yeah, they're really out of range. They can be considered outliers, but we know they're not, okay? But for our model, they're bad. I mean, now let's evaluate our model, okay? So we're gonna import our metrics. Let's import mean, absolute error as well. So let's use these three are the most common ones for metrics for evaluating the model. So we're gonna use like y, yeah, but that's not. So yeah, we're gonna use predict function to predict our model, to make the test predictions. So now we're using our test data set here, okay? Now let's use our evaluation metrics here, MSC, my, and R2. There are some functions we imported here, so we just pass the function and we pass our test and our prediction. Okay, so it's gonna evaluate the actual value and the predicted values. Now we can print them. Okay, 5,000. Okay, that's a pretty high one. Mean absolute error 61. Well, we can test with special attack later. I'll test it with special attack, but I don't think it's gonna change that much. Visualize with the test data. So we just do plotter with test, white test, okay. But this plot here, well, it's basically the same as this one. Actually, where is it? Actually, this one is wrong. It should be train, okay. So yeah, that should be our model here, okay. Train, and yeah, train. And now we can visualize with the test data. There we go. That's our model trained, and basically that's it. We trained our model to our data. We can test with special attack to see if it's gonna change these values here. Yeah, I mean, we run that. Can run that and regression special attack. Pretty long name. Don't do that. Let's run a model. I can visualize if you want, but it's gonna be special attack, so a little bit different. And now I can predict with okay, it's wrong by the way. Oh my god, it should okay, this one is wrong as well. So we run that, now I can visualize, okay, now that's right. And now we have our evaluation here. So 5,686, and this one is 5,940. Yeah, so special attack has a lower MSC and lower MI, and probably closer to 1 R2, right? 58, and this one is 56. 56, yeah. R2 is closer to 1 is better. But basically that's it, our hands-on on simple linear regression. We can just change the data now, we can add some data,